This video is a continuation of an exercise of CVP calculations based on a single data set. So, in order to continue with items 6 through 9, we need to go ahead and remind ourselves what some of the key figures were in the first set of calculations that we did. So I'm going to write over here to the side, contribution margin per unit is $2.50. The contribution margin ratio is 0.125. Total variable costs are $17.50 per unit, and the total fixed costs are $290,100. If you have questions about the calculation of any of these items, please go back and refer to the first video from this series. Let's also refresh our memories on the abbreviations that I'm going to use while walking through the solutions to this next set of calculations. I'm just going to list them all right here to the side. Now that we've gotten our reminders out of the way, we can start working on our next set of calculations. So the first item that we're doing is the break-even point in units. Break-even means operating income is exactly zero. There is no operating profit and there is no operating loss. Here's the equation to calculate the break-even point in units. Break-even in units is fixed costs divided by the contribution margin per unit. So, as we already established, fixed costs are $290,100 and contribution margin per unit is $2.50. So, to calculate break-even, we simply divide and get a break-even units of 116,040. This means that Johnny's Manufacturing must sell 116,040 units in order to break even each month. Now let's move to item 7. We are calculating a new break-even point if our direct labor costs increase by 10% and our fixed costs also increase by $22,500 every month. This is called a sensitivity analysis, which means we are calculating what happens to our break-even if some of our costs change. I'm going to break this down into a series of steps. Step number 1, calculate the new contribution margin as a result of the change in variable costs. We know that direct labor costs has increased by 10%, so we go back and look at our direct labor, and it has been $7 per unit. So now we need to make direct labor go up by 10%, which would make it now $7.70 per unit. When we add up our new total variable costs, we get now $18.20, and our contribution margin per unit drops to $1.80 per unit. Now we are ready for step 2. In step 2, we are going to calculate our new total fixed costs. So we will take our original fixed costs, $290,100, and we're going to add $22,500, which is the amount that fixed costs are going up under our sensitivity analysis. Add those together and get our updated fixed costs of $312,600. Now we are ready for the third and final step. All that we have to do now is use our new contribution margin per unit and our new fixed cost total and plug them into the formula for break-even units, which is fixed cost divided by contribution margin per unit. We plug in our new values and we calculate a break-even rounded to the nearest unit of 173,667 units. Here we can see that if our fixed costs increase and our direct labor increases, our break-even point will increase, which makes sense because now we have to sell more units to cover our increased costs. Now we can move to the next item. We're going back to our original data, meaning our original fixed costs, our original variable costs, and now we're going to calculate the break-even in revenue dollars. So instead of solving for the number of units that a company needs to sell to break even, now we are solving for the dollar amount of revenue that a company needs to achieve in order to break even. The formula for break even in revenue dollars is fixed costs divided by the contribution margin ratio. As we talked about at the beginning of this video, we have already determined that the contribution margin ratio is 0.125 and total fixed costs are $290,100. So we simply need to plug those values into this equation to calculate our break-even revenue at $2,320,800. So we have just determined that Johnny's Manufacturing needs to achieve this dollar amount of revenue every month in order to break even. Now let's look at our final calculation for this video. How many units need to be sold to generate operating income of $260,100? This is called a target profit calculation because we are solving for the number of units that must be sold to reach a target level of operating income. The formula for this is very similar to the formula for the break-even number of units. All we have to do is take the fixed costs and add the target profit to the numerator, and then we're going to still divide by the contribution margin per unit. So let's go ahead and plug our figures in. Fixed costs are $290,100. Our target profit is $260,100, and we're going to divide that sum by our contribution margin per unit, which is 2.5. The result of that calculation gives us 220,080 units. That means that in order to generate exactly $260,100 of operating income, Johnny's Manufacturing must sell this level of units. And this concludes our second set of CVP calculations for our Johnny's Manufacturing dataset. Now we can move along to our third step in the next video.